Here we have a SAT math problem. Okay, let's go to the question. In the system of equations above, k is a constant. The function y equals to f of x is shown in the xy plane above for negative 8 less than or equal to x less than or equal to 14. On this closed interval, for how many values of k does the system have exactly 4 solutions? Okay, here when I look at the graph, we have the graph from the value of x, that is negative 8 to positive 14. That is, in this interval only we have the graph of this equation, that is y equals to f of x. Okay, here we have to find the value of k in the second equation, for which this system has exactly 4 solutions. Okay, here let's consider the number of solutions for the system of equations. Okay, so whenever I want to find the number of solutions for the system of equations, I have to find the number of points the graphs of two equations intersect. Okay, here for this system of two equations, I want to get the number of solutions. I have to find the number of points at where the graphs of these two equations intersect. Already we have a graph for the first equation over here, that is y equals to f of x. And now we have to sketch the graph for the second equation. Okay, so for that we have the values for the constant k in the given answer choices. Okay, now let me consider answer choice A. So that is we have the value for k, that is 1. Okay, when I plug in k equals to 1 over here in this equation, I am getting y equals to 1. Actually, the graph of this equation is an horizontal line through the value 1 on the y-axis. Okay, here we have the value 3 on y-axis, then we have 2 over here and we have 1 over here. Now let me draw an horizontal line through the value 1 on the y-axis over here. Okay, now I have drawn the horizontal line. This is a graph of the equation y equals to 1. And so this is the graph of the first equation y equals to f of x over here. Okay, to find number of solutions for the given system of equations, I have to count the number of points of intersection of the graphs of these two equations. Okay, now let me count over here. So this is a point of intersection. This is a point of intersection. This is a point of intersection. And here we have a point of intersection. And here we have. Okay, here 1, 2, 3, 4, 5. So the two graphs intersect at 5 points. So the given system has 5 solutions when k equals to 1. But according to the question, we have to find the value of k for which the given system has exactly 4 solutions. So when I consider the value 1 in answer choice A, so I am getting 5 solutions for the given system. So the value I have in answer choice A cannot be the value of k. That is 1 cannot be the value of k. We can reject answer choice A. Okay, now let me erase the stuff over here. Okay, now we have to consider the value in answer choice B. So that is 2. So let's take this value 2 for k over here. Then this equation will become y equals to 2. Again, we get an horizontal line as graph for this equation through the value 2 on our y-axis. Already we have 2, the value 2 we have on y-axis. Now let me draw an horizontal line through this value 2 on y-axis over here. And also the same thing, we have to count the number of points of intersection. Okay, 1, 2, 3, 4, 5. Okay, the graphs of two equations in the given system intersect in 5 points. That is, when k equals to 2, the given system has 5 solutions. But we have to get to 4 solutions according to the information. So now what we can do is we can reject the answer choice B as well. Okay, now let me consider the value 3 in answer choice C. Okay, now let me plug in this 3 for k over here in the second equation, that is y equals to 3. So this is an horizontal line through the value 3 on the y-axis. Okay, now let me draw an horizontal line through the value 3 on the y-axis over here. Okay, here I have drawn an horizontal line through the value 3 on the y-axis over here. Let me count the number of points of intersection. 1, 2, and here 3. And here we have 4. Okay, when I take k equals to 3 into the second equation, so the graphs of these two equations in the given system intersect in 4 points. So therefore, we have 4 solutions for the given system of equations when k is equal to 3. So it meets the condition given in the question, because we have to find the value of k for which the given system has exactly 4 solutions when k is equal to 3 in answer choice C. So the given system has 4 solutions. So the correct answer choice for this question is C. Anyways, we can verify answer choice D as well. So in answer choice D, we have the value 4 for k. So when I plug in k equals to 4 over here, we get the equation y equals to 4. Now we have to draw an horizontal line through the value 4 on the y-axis over here. So here we have 4. Let me draw an horizontal line through the value 4 on y-axis over here. Let me do it. Let me count the number of points of intersection: 1, 2, and 3. Okay, when k is equal to 4, the graphs of the two equations intersect in 3 points. That is, we have 3 solutions for the given system when k equals to 4. But we need to get 4 solutions, so we can reject answer choice D. Okay, already we got that when k equals to 3, we got exactly 4 solutions for the given system. Therefore, the correct answer choice for this question is C.